There's nothing there. And here. Good afternoon, class. Today we're going to be looking at solving absolute value equations. This is assignment number 6, and I got to click on all these videos so that I can access the problems. Somewhere along the way this semester I'll stop doing that. It'll be just you can access the problems immediately, but you'll want to click on the media if you want to make 100 on the homework. You got to click on it to get credit, even if you don't need to watch the videos. And I need to do a little talking first. Okay, here we go. These large vertical bars that I just drew represent the absolute value of a number. N is equal to the distance from 0 to n on a number line. The absolute value function is the absolute value tool measures the distance from a number to 0 on a number line. For example, if I wanted to know the absolute value of 5, you're looking at a number line. There's 0, 1, 2, 3, 4, 5. How many units from 0 is the number 5 on that number line? If you counted it, what would you get? 5, okay. Suppose instead of the absolute value of 5, how about the absolute value of -5? The absolute value of -5. How far is -5 from 0 on a number line? And let me ask you something. If I said, oh, you're sitting -5 feet away from me, would that make sense? No. The distance from -5 to 0, -5 is over here on this side of the number line. But when you count the distance is still a +5, correct? So it doesn't matter whether you have a positive or negative number inside those absolute value bars. When you take the absolute value, you're going to get what? Okay, that positive n. Okay, I have a few others. Okay, here's an example. How about the absolute value of 0? How far is 0 from 0 on a number line? 0. If you're sitting there at 0, how far do you have to move to get to 0? Nothing. You stay where you are. Oh, I think I'll change it up a little bit. I want to know what numbers can I put inside that absolute value to get, let's say, a +3. What numbers can you take the absolute value of to give you a +3? 3 and -3. I'll write it as positive or -3. The absolute value of 3 is 3. The absolute value of -3 is still +3. Okay. Oh, I have a good one. How about what can you take the absolute value of to get -7? What can you put inside those absolute value bars so that the absolute value equals -7? The common mistake is people say -7, but if you take the absolute value of -7, are you going to get a -7? No. What about a +7? If you take the absolute value of a +7, are you going to get a -7? No. So I'll say nothing. The absolute value of nothing is going to equal a -7. We have 3 cases as we look at absolute value equations today. I think I'll write those down here. Okay. I'll say 3 cases for absolute value equations. If you took Math 371, you may have solved, I know we used to solve absolute value equations in Math 371. It's been several years since I taught it. I may have changed things up, but even if you haven't seen it, these 3 cases are pretty painless. The first one, I think I'm going to Roman numeral them. Case number 1. You have an absolute value equaling a positive number. Okay, like this one here, there was a 3 there. The stuff inside there had to be a positive or -3. So I'll say, in that event, you expect to have 2 solutions. The absolute value has to equal the positive number and the negative of that number. The second case, oh, by the way, do we have any new faces here? Do we have any new? No. Okay. We're going to have a visitor to the classroom one day. I don't know when, but one day. So don't be shocked if you come in one day and there's a visitor. Okay. Second case, this is a nice one. Absolute value equaling 0. The only thing that can that can give you an absolute value of 0 is 0. In that event, you expect only 1 solution. Third and final case, you have the absolute value by itself on the left side, equaling a negative number. When you have the absolute value by itself on one side and a negative number by itself on the other side, what do you conclude? How many solutions will there be? No solution. Because no matter what happens inside those absolute value bars, when you take the absolute value, you're going to get a positive quantity. So I'll say no solution. And this is number 1. Number 1. Let me write this down. We have the absolute value of x. The absolute value of x is equal to 16. The instructions just say solve the equation. Okay. This is a positive number. We have an absolute value by itself. We have a positive number on one side. That means we expect there to be, when you have an absolute value by itself and a positive number on the other side, you expect 2 solutions. I'll make a little note of that. Well, actually, I didn't need to write that down because there's not really any work left here. What does x have to equal so that when you take the absolute value, you get 16? What numbers have an absolute value of 16? 16 or negative 16. So we'll just type in plus minus 16. I hope they have the plus minus hot button here. Let's see. You click. Notice, remember I told you that hot button, that plus minus hot button is a relatively recent invention that they programmed in. You used to have to type 16 comma negative 16. That's why they say use a comma to separate the answers. But in this case, there's no need to. You can just put plus minus 16. What about this next one? Let me write it down. We want to know, what can we take the absolute value of to give us a negative 9? What do we conclude here? No solution. It doesn't matter what you put in here. Whatever you put in, whether it's positive or negative, when you take the absolute value, the result's going to be positive. So, no solution. I think that's an option. I think that's the B option for the answer. You don't type in no solution. I think there, the solution set is the empty set. Okay, well, I think I'd like it better if they just said no solution, but I'm not going to badger Pearson to change that. They do the important stuff, in my opinion, like put in the plus minus when we complain enough. So, any questions there? It can't stay this easy. You're not always just going to have a variable inside. Yes.
Between the x that equals negative 9 that is equal to no solution?
Yeah, because no matter what you put inside those bars, no matter what you put inside here, when you take the absolute value, you're going to get a positive number, not a negative number. It can't stay this clean. You're going to wind up with algebraic quantities inside the absolute value bars, okay? You're not just going to have the single letter x all the time. We have the absolute value of x minus 3 is equal to 28. To solve an absolute value equation, you must have that absolute value isolated. The three cases that I wrote up only work when the absolute value is by itself. That's what I was saying. You have an absolute value by itself on one side, a negative number on the other side, or the absolute value on one side, 0 on the other side. In this case, we have the absolute value on one side and a positive number on the other side. That's what we have here. And I'll tell you right now, this case 1 is the most common case. So we have an absolute value equaling a positive number. That means the stuff inside there has to equal 28 or negative 28. So x minus 3 has to equal a positive 28, or x minus 3 equals a negative 28. Just like right here, x had to equal a positive 16 and x had to equal a negative 16, but you already had the x isolated. Here the x's aren't isolated. What are we going to do to get x by itself here? Not subtract.
Divide?
Not divide.
Add it.
Add 3. Add 3.
Oh, and then
Pick up the 3 and move it over to the other side to give you x equals 28 plus 3 is 31. That's the first solution we found. Here, add the 3 again to give me x equals
25.
negative 28 plus 3. Be careful. It's not just 25. It is a negative 25. For the second solution, realize your answers aren't always going to be the positive and negative of the same number. If the stuff inside the absolute value is something other than just a single x, you don't expect to get the positive and negative of the same number. Here we have a positive 31 and a negative 25 for our answers. So you have a positive 31 and a negative 25. And you know something, before we go on, I'm going to make up an example. There's a point to this. The absolute value of x minus 4 minus 18 equals, let's say, negative 3. Two solutions, one solution, or no solution?
No solution.
That's the common mistake. You cannot make the decision until the absolute value is by itself. You see that negative there and you think no solution. You cannot decide until the absolute value is by itself. What do I need to do to get that absolute value by itself? I don't want that minus 18 there. Add 18. I'm going to move the 18 to both sides to give you the absolute value of x minus 4 is equal to negative 3 plus 18. That's a positive 15. Now this is a case 1. We have absolute value on one side, a positive number on the other side. Before you decide on which case, you must isolate the absolute value. I think I better write that down, but let's finish this off. We now have an absolute value equals a positive, so that's a case 1. That means there are two solutions. X minus 4 will equal positive 15, or x minus 4 will equal negative 15. What will I do to solve this x minus 4 equals positive 15? Okay. To give us x equals the first one, 15 plus 4 is 19. There's one of my solutions. What will I do here to get x by itself? Okay. Add the 4 again to give us, okay, negative 15 plus 4 is negative 11. Any questions? Better than what we were doing the last time? Yes or no? Yes? It should be a lot better. From a teacher's point of view, it's a lot easier. So from y'all's point of view, oh, wait a minute, I made that problem up. Okay. But do y'all see what the point of that problem was? Before you can decide how many solutions you're going to have, you must isolate that absolute value. And I'm writing that out. Let's see. I'm going to write that out. You must isolate the absolute values before deciding, I'm running out of room, how many solutions you'll have. I should have just written, always isolate the absolute values first. The reason we're solving absolute value equations today is on Wednesday we're going to be solving inequalities, and some of those inequalities are absolute value inequalities. The first step in solving the inequality will be to solve the equation, and the same thing is true. When working with absolute values, whether it's an equation or an inequality, you must first isolate the absolute value expression. Now, what's number 4? Okay. We have the absolute value of 4x minus 7 is equal to 8. Absolute value of 4x minus 7 is equal to 8. Okay. Am I going to have to, do I have to isolate the absolute value first, or is the absolute value already isolated? It's already isolated, okay? Somewhere along the way, we'll start getting somewhere it's not already isolated. And if you look back, which case am I going to have? 2 solutions, 1 solution, or no solution? We have an absolute value equaling a positive number, absolute value equaling a positive number, so we'll have 2 solutions. That means 4x minus 7 has to equal positive 8. Or what's the other case? 4x minus 7 equals a negative 8. Oh, there. What will I do first here? Add the 7, move the 7 over, whatever you want to, however you want to think of it. You're going to wind up with an 8 plus 7 on the left-hand side, on the right-hand side. So you have 4x equals 15, and then divide by 4 to give you x equals 15 over 4 for my first solution. (4x minus 7 equals negative 8. What will I do first? Again, I'll add the 7. Get that 7 over on the other side to give me 4x equals negative 1. And then divide by 4 to give us x equals negative 1/4. For my second solution. Hopefully it's clear why we're doing this. The only way you're going to have an absolute value equaling 8 is for that stuff inside there to be 8 or negative 8. So we set that inside stuff to positive 8. We set it to negative 8. So 15/4. Do not put the comma in the denominator. The programmer may have accepted that, okay? They may have fixed it so that it would work, that it would accept it with that comma down there. But once we get to the next step, where you're going to have a lot of commas and parentheses typing in, if you put the comma in the denominator, they count it wrong, and they don't tell you, hey, look at how you've enter the information. They just say wrong. So use the right arrow to get out of the denominator, or tap with your mouse, comma, -1/4. Any questions? Well, it'll get a little harder than that. Let's see. Okay. Maybe not much harder though. Number 5. The absolute value of 8x minus 6 is equal to 66. The only thing that's in the absolute value bars here is the 8x. There's only one correct next step. What is it? Okay, we have to, before we decide on cases and you say, oh, it's going to be positive over here, before you decide on the case, if you say equals a positive 66 and a negative 66, your answers are going to be wrong. You have to get the absolute value isolated by adding that 6, get it over on the other side, and then you have the absolute value of 8x is equal to 66 plus 6 gives me a 72. I'm trying to make those absolute value bars in another color so it doesn't look like an 18x1. That's why I'm changing colors the way. That is not 18. That's an absolute. Those are the absolute value bars. So it's an absolute value equaling a positive, which means we're going to have how many solutions? 2 solutions. So you set 8x equal to positive 72, or 8x equals negative 72, I agree. And then what? For this one, divide by 8 to give us x equals 72 divided by 8 is a positive 9. Here, the second case, okay, divide by 8, and it gives you a negative 9. I'm feeling sort of lazy today, so I think I'll just type in a positive or negative 9, rather than using a comma, 9, comma, negative 9. How does that sound? I'll use that. I'll take advantage of that little plus minus key they have there. Plus minus 9. Any questions there? Okay. There's only seven problems in this assignment, so we had to get something a little messier, don't you think? So here goes. We have the absolute value of the fraction 2x minus 7 over 7 is equal to 5. Is the absolute value isolated, or do we need to move terms around? It's already isolated. It's a messy expression inside there, but there's nothing being added to or subtracted from or anything with the absolute value. So it's already isolated. We have an absolute value equals a positive number That's not good. It looks like 11 equals a positive number. I better write absolute value. Absolute value equals a positive number. How many solutions do we expect? 2. I'm just making a note of that. So the stuff inside, 2x minus 7 all over 7 has to equal a positive 5, or what's the other, or a negative 5. 2x minus 7 over 7 equals a negative 5. When I look at this, I think I can turn this into a proportion. Rather than bothering with the least common denominator, I can say that 5 is the same thing as 5 over 1, and then what can we do? We had a little trick when you had fraction equals fraction when it came to solve. Cross multiply, that's right. We can cross multiply. You take the 2x minus 7 times 1. Oh, that's so easy, I can just write that down. What's 2x minus 7 times 1? 2x minus 7 equals, cross here. 5 times 7 gives me 35. And we need to get x by itself. There's only one correct next step. What is it? Move the 7 over. So I'll add 7 and I'll add 7. That gives me 2x equals 42. And then divide by 2. 42 divided by 2 gives me 21. There's my first solution. I think I'll do the same thing for the negative possibility. We have that negative 5. Think of that as negative 5 over 1. You multiply 2x minus 7 times 1. That stays at 2x minus 7 equals, here we have a negative 5 times 7. What's that going to give me?
Negative 35.
Negative 35, I agree. Well, it seems so worn out today. What was going on yesterday? Was this Sunday?
I worked.
Huh?
I went to work.
Oh, no. Okay, well, I remember teaching those 8 o'clock classes Monday mornings. Oh, I tell you.
So early.
I didn't have a problem because I went to bed at 8:30. That's the secret. If you have to get up early in the morning, you have to go to bed early the night before. That's how I made it 30-something years doing that. But, no more. I'm waiting for y'all to tell me what to do here.
Oh, at the
Add the 7. Okay.
And then add on the other side.
Okay. So we have 2x equals.
Bring down the 2 and then over 2.
Okay. Negative 30. 5 plus 7. Did I hear negative 28? And then divide by 2 to give me my second solution of negative 14. Any questions there? As I said, the most common situation is absolute value equals a positive number. So we have, oh, and the order in which you type these numbers here doesn't matter. You could put 21 comma negative 14. You could put negative 14 comma 21. Just the solution is 2 numbers. There they are. Any questions? Last one. I have a few other things I want to do. when I'm through with this, so don't start packing up as soon as we're through with this. I said it would be a fast, easy class today, but not that fast. There's some other stuff we need to do to get ready for Wednesday. Okay, we want to solve the equation. The absolute value of, that's a m like money, plus 5. I know my m's and n's sound alike. So m like money, not n like Nancy. Oh, let's figure out a way to take over the world. That's one of those things. Unless there's a reason to use m or n as a variable, unless there's a specific reason to use something else, I think I'll order that the whole world has to use x as a variable. X is a good letter. I tell you what I hate is when we start using y's, because the y's, they go down low. They mess up the next line, you see? So that's another one of those things. There's only one correct first step here. I'm not going to say what it is. Y'all tell me. You've got to get the absolute value by itself. So minus 1, minus 1. That says we have an absolute value of m plus 5 equals, I agree, 31 minus 1 is a 30. So now we have an absolute value equals a positive number. How many cases do we expect to have here? 2. That m plus 5 has to equal positive 30, or
M plus 5 equals negative 30.
equals a negative 30. What will we do to solve this first one? So we're minusing the 5 to give us m equals
25
25. Good.
over M.
Oh, that's a 25. And here,
Negative 5.
negative 5.
On the other side, and then positive 25.
Wait a minute, be careful. You're
Oh, no, it's
$30
negative.
in debt and you went and spent $5 more. I think that would be negative 35. You're now $35 in debt. Back in the olden days with those old-fashioned checkbooks, my sister, she couldn't have done a math problem involving negative numbers if her life had depended on it. But it was amazing. Back in the olden days, you could go negative on the checking account because you could write the check, say on Wednesday, you'll get paid on Friday and deposit the check in to cover the amount. But our sister, she would be, she's negative $120. She went and wrote a check for $28.42. She knew exactly how much she was in debt. She didn't have that balance on her checkbook register perfect, but if you just told her, here's negative 120 minus 28.73, what is it? She'd have no idea. Any questions there? The next time, we're not through yet, but the next time we're going to be solving inequalities. Those are things with less thans and greater thans appearing. The first step to solve an inequality will be to replace the inequality with an equal to and solve the equation. That's why we need to know how to solve absolute value equations. This absolute value equation will pop up, or something like it. Here's one that's going to pop up in the next assignment on Wednesday, or something real similar to it will pop up. You know how MyLab changes numbers, so we have the absolute value of x squared plus 2x. Oh, I'm still writing it down. Let me write it down. Is equal to 10. X squared plus 2x, and we write it down. Here it is. Thanks for reminding me to switch it over. So the absolute value of x squared plus 2x minus 25 is equal to 10. Is the absolute value isolated? Yeah, it's isolated, and it's an absolute value equaling a positive number. It's an absolute value, here I'm thinking, absolute value equals a positive number. That means the stuff inside there, x squared plus 2x minus 25 must equal a positive 10, or x squared plus 2x minus 25 is equal to a negative 10. There's a fundamental difference in this example versus the problems we've been doing. What's the big difference? This is quadratic. This is quadratic, the x squared. So we're going to have to remember, how do you solve a quadratic equation? Well, either factoring or quadratic formula is what we prefer. Either way, what number do we need on one side? I couldn't hear you. What number do we need? If we're going to solve by factoring or the quadratic formula, we need what number? On 0? Okay. So I'm going to have to write small here. And I'm going to draw a little line. I'll do the work for this equation on the left. I'll do the work here for that one on the right. We're going to have to move that 10 over by subtracting 10. That'll give me an x squared plus 2x. Negative 25 minus 10 gives me a negative 35 equals 0. We haven't factored today, so this is a good chance for you to practice your factoring. It's a simple trinomial. It's a simple trinomial. I'll write down my two sets of parentheses. The first possibility, 1x squared. What times what equals 1? Just 1 times 1. A simple trinomial is when the leading coefficient is a 1, and it's simple to decide that term because those first terms, because you know it's just going to be 1x and 1x. Uh-oh, what do we know about the signs? Look at that last sign. I couldn't hear you. A plus and a minus, I agree. I'm going to make a note right here. You're going to have 1 plus and 1 minus. I think I'll go ahead and write them as a matter of fact. Since the first terms are both x, I'll just put the plus first and then the minus. Now 35. What times what will give you 35? I can only think of two pairs of counting numbers. 1 times 35 or... Okay, I'll put them in numerical order just because that's my habit. 5 times 7. For a simple trinomial, you choose the pair that adds or subtracts to give you what?
2.
2?
Positive 2.
Positive 2. So play around. It's going to have to be 5 and 7. So 7 minus 5 is 2.
The 17 on the plus.
Okay, the bigger one, the 7 goes with the plus. And then the 5. Foil that out in your head. Check that outer and inner product. Are we going to get back a plus 2x?
Yes.
What's the outer product?
Negative 5.
Okay, x times a negative 5, I agree, is a negative 5x. What's the inner product? 7 times x.
Positive 7x.
That's a positive 7x. Negative 5 plus 7 gives me a positive 2x. Is that what I needed? Yes, it is. Yes, it is. But don't stop. You still got to set each factor equal to 0. X plus 7 equals 0 means that x is equal to
Negative 7.
negative 7. I agree. So there's my first solution. Set x minus 5 equal to 0.
Positive 5.
Okay. And there's my second solution of positive 5. So we're going to have more than two solutions here. We had two cases. We got two solutions from the positive case. Now we need to find the solutions that come about from this negative case. Any questions before we continue on? We're halfway through. We got to do the negative possibility. What will I do first?
Add the 10 to the other side.
Add 10. That gives me,
Negative 15.
okay, so you have an x squared plus 2x minus 15 is equal to 0. And I didn't say use the quadratic formula, so it's factorable. Now, once again, like when you're doing the homework, you're assuming you don't have a time limit, you can practice with your factoring. Now, if this were a test and you just didn't see the factorization after a minute or so trying to factor it, what should you do? If you're working on a time limit, should you continue trying to waste time factoring it or what? If you don't see, the rule I use is if I don't see the factorization very quickly, I go to the quadratic formula. Either way, you have to have it set up like that, set equal to 0. So if you don't see the factorization real fast, go on to the quadratic formula. I know the first terms. Once again, I know those. X and x. 1x times 1x gives me that 1x squared. And I know the signs again. The last sign is still a minus, so plus and minus. 15. 1 times 15, or what's the other one? 3 times 5, so 1 times 15 or 3 times 5. Which one should we use? It's a simple trinomial, so you can look and tell. Okay, remember that the pair has to add or subtract. In this case, it subtracts to give you that positive 2x. Play around with it in your head to get that plus 2x. What should go after the x plus? The larger number goes with that sign right there. The plus, the larger number, 5, and then the smaller number. And once again, if you want to check, the outer product is negative 3x. What's the inner product? Positive 5x, negative 3 plus 5, that gives me a positive 2x. You know, I'm really beginning to like using this paper over here, this side for scratch work. I'm beginning to like that. I am. Oh, we're not through, are we? Set x plus 5 equal to 0, that gives me negative 5. Set x minus 3 equal to 0, and that gives us positive 3. So how many total solutions do we have here?
4.
We have 4 solutions. And we will run into a quadratic absolute value inequality the next time. And the first thing you'll have to do is solve the quadratic absolute value equation. And this first, solving the equations are the longest part of this cut point method that we'll be seeing the next time. The next time when we're solving inequalities, we're going to go through a process of creating number lines. They'll have some intervals on it. Some of them will be shaded. Some of the intervals are going to be crossed out. The last step will be to express the shaded intervals using interval notation. So I think this is a great opportunity right now. We haven't even been going an hour. I think we can review interval notation just for a few minutes. That'll make things smoother the next time. Interval notation. This is something you would have seen somewhere along the way in other math classes, but it's pretty easy. Anything that's real easy is easy to forget also. So with interval notation, we have a number line. I'm going to be drawing number lines the next time. There's 0, and we have some mark there and there. What we'll be doing the next time, we're going to go through this process to create numbers that are called cut points. They cut up the number line. 1, 2, let's say we have a closed dot at -3, and here's -1. We'll have an open dot at -1, and there's 2. Let's put another open dot. And here's 4. We'll have a closed dot there. Realize, do number lines ever stop? Do they ever stop out here? No. So I think I'm going to put right above that little arrowhead, I'm putting a positive infinity. That means it keeps going and going forever. What about over here? Does this side of the number line ever stop? No. So I'm going to put a negative infinity there. Just to make a note that you're going and going forever to the left and forever to the right. Once you find these little magic cut points that you have labeled on the number line, you're then going to test the intervals to decide if the inequality is true or false at those test values. And just for this sake, I think I'll assume an alternating pattern. I'm going to say it's true here, so we're shading it. The next interval from -3 to -1, that's false, so we cross it out. We do a little more magic and decide to shade this interval. And we test and decide to cross out that interval. And this last interval, I'm just assuming an alternating pattern because that's usually what's going to happen, you'll see the next time. If the first one is shaded, odds favor the next one won't be shaded. So you go through we're going to be going through all this stuff, and we'll, this old cut point recipe that we'll be using, and we're going to wind up with a number line like this. The last step in the cut point method is to express the shaded intervals using interval notation. So that's what I want to do. Express the intervals, the shaded intervals, using interval notation. Uh-oh, I'm getting timed out on it. There. Okay. Is it still recording? Yes. I'll get us started. With interval notation, it's essential that you go small to big. You look at that first shaded interval here. The left-hand endpoint, well, that thing never stops. It keeps going and going forever to the left. So what we're going to do, whenever it's going forever to the left, you'll put a parenthesis and a negative infinity. There's no left-hand endpoint. You always precede a negative infinity with the parenthesis, and then you type a comma. The right-hand endpoint is a -3. We have a closed circle at -3. In that event, you're going to type a rectangular bracket. You use rectangular brackets at the closed circles. You're going to use parentheses everywhere else. So this is saying all the numbers to the left of -3, including -3. All the numbers to the left of -3, including the endpoint -3, or there'll be a hot button for a little union symbol that you'll have to type. So all the numbers to the left of -3, or now we want all the numbers between -1 and +2. Those open circles are saying we're not including -1. It's just the numbers to the right of -1 and the numbers to the left of +2. For open circles, you put a parenthesis. The left-hand endpoint is a -1, comma. The right-hand endpoint is a +2. There's another open circle, so you put another parenthesis. The only time you use a rectangular bracket is when you have a closed circle. At infinities or open circles, you use parentheses. Or there's a third interval that's shaded. What's the left-hand endpoint? Remember, you must go small to big. For this third interval, because it's closed, we'll have a bracket, and then a +4, comma, positive infinity, parentheses. I'll have people, there's an infinity hot button on the toolbar, but there isn't a negative infinity hot button. To type a negative infinity, you have to type the negative, the dash from the keyboard, and then hit the infinity hot button. I'll have people emailing me, there's no negative infinity hot button. That's right. They only have the positive infinity. If you want to type a negative infinity, you'll have to type the little minus sign. You only use rectangular brackets at closed circles. Use parentheses at open circles or at negative infinities or positive infinities. Is that familiar to y'all from anywhere? Yes. Let's just do one more just to make sure you have the hang of it.
I didn't like learning these. I wasn't very good at these.
Okay, well, I'm telling you right now, it's not bad, okay? It's not bad. You just got to remember, the only time you use a rectangular bracket is at a closed circle. And you'll be wondering, well, how will you know when to use a closed circle? That's part of the cut point recipe we'll be doing on Wednesday. Let's do another one. Okay, I'll say -7, 3, +7, and 9. And let's see. I think I'll just alternate again. I'll say, the last time I didn't alternate. This time I'll just alternate. Open, closed. Open, closed. And, oh goodness, okay, there. And you'll see that we're gonna, in most cases, once you see that one interval is, let's say this one is crossed out. Oh, goodness. What happened now? Watch me, I messed up. There, is it still recording? I need to keep moving the mouse so it doesn't cut off. So let's say this one is crossed out. This one is shaded. Here's crossed out, shaded, and crossed out. We only have to express the shaded intervals. So let's look at the first shaded interval. This is all the numbers between -7 and +3. You don't include -7, but you do include +3. That's what this number line is saying. All the numbers between -7 and +3, excluding -7, but including +3. Pretend we're typing in our answer. What will I type first? A parenthesis or a bracket? A parenthesis because it's an open circle. Parenthesis, and then my left-hand endpoint or cut point is -7, You'll have to type a comma. If you don't put a comma, they're going to count it wrong. What's my right-hand endpoint? 3. What will go after the 3?
Bracket.
A bracket because it's shaded. Or, and this thing will come from the toolbar. Just like the infinity will come from the toolbar. Now the second interval, parenthesis or bracket, parenthesis, 7, comma, 9, bracket. Only use a bracket at a closed circle. Use parentheses for open circles and use parentheses for infinities or negative infinities. Any questions there? Yes.
What you're saying is the number line with an open circle, you put a parentheses in front, and when the dot is shaded, you put a bracket.
That's correct. Now realize you may have your number line may look like this. We'll have a way of, the most common situation is two cut points. Let's say 3 and 5. You may not even have any open circles. You may have closed circle, and let's see, it may be shaded, crossed out, shaded. Well, I don't see an endpoint here on the left-hand side, so we assume negative infinity here. Call it out as if you were typing it in. What would you type first? What always precedes a negative infinity?
A negative infinity.
Before negative infinity, you must type a parenthesis, and then the negative infinity, comma,
Bracket.
3, and the bracket, union.
Bracket.
Okay, you have a closed circle, you go bracket, 5,
Infinity.
and what goes after a positive infinity? Always a parenthesis. Only use a rectangular bracket at a closed circle. Only use a rectangular bracket at closed circles. Anywhere else you're using parentheses. Some of y'all may have not used open circles and closed circles when you did interval notation. It's possible they would have done this. In place of the closed circle, they'd put a bracket facing towards the shaded area. I don't like that method because,
I think that's what I was taught.
okay, you see, I don't like that method because the bracket has to go towards the shaded area. When you're labeling the cut points on the number line, you won't know which side's going to be shaded until after the cut points are labeled. So once you've decided how they're shaded, you then got to go back and mess with the cut points more. That's why I dislike that. But there is a trend, some textbook authors and some MyLab programmers, what they do is, okay, that's an open circle, so they put a parenthesis there. That's a closed circle, they put a bracket there. I don't care for that just because you don't know. When you're labeling these numbers, when I'm labeling the numbers the next time, the cut points, I'll be labeling them as open and closed while I'm doing that. But if you're using the brackets and the parentheses on the number line, you won't know, well, will the bracket face the left or is it going to face the right? Any questions there? Y'all think we've done enough for today? Have I done my penance for punishing y'all with that last assignment?
Yes.
Yes, okay. Okay, then any questions you want recorded?
Um,